Hello guys, welcome back to the channel Space Fact and Science Fact. So please subscribe my channel for more interesting videos and click on bell icon so you will get more notification of my interesting videos. So let's start this video. Black hole facts, a space guide to black holes. Black holes are both strange and amazing, and the study of them has kept scientists busy and excited for the past century. They are an area of space that nothing can escape from once it has entered it. Not even light. The ability to absorb all light around them and the way they reflect none of it is why they are referred to as black. So far, astronomers have found evidence of black holes in a lot of places in the observable universe. The parts we can see from Earth using powerful telescopes and other instruments. And special type of black holes, supermassive black holes in the center of almost our galaxy, even our own. Our galaxy contains many less massive black holes as well, which are the result of stars reaching the ends their lives and going through a special process. History of black holes research and discovery. In 1783, John Michell thought that something could be big enough and heavy enough process enough mass that to escape from it you would have to be traveling at speed of light. Gravity becomes stronger with the more massive something has. So something with a lot of mass would make it very difficult to escape from it. You can see a demonstration of this in the huge amount of fuel it takes a rocket to travel away from the ground fast enough to escape the Earth's gravity caused by its mass and enter space. That speed is called escape velocity. Mitchell also thought that some things might be even more massive and it would require more than light speed to escape. His theory originally caused some excitement in the scientific community, but when it was discovered that light has a wave-like pattern, many scientists decided that gravity could not affect it. They were wrong. In 1915, Albert Einstein was at work on his theory of general relativity. General relativity is a compacted theory that states that mass causes space and space-time to bend or curve. Anything that is in the motion will seem to flow along the curve, with, which is gravity at work. Secondly, light has a constant speed and it if light seems to be moving at different speed, it is on one of these curves in space-time. It is being acted on by gravity. Soon afterward, Carl Schwarzschild, who was fighting in BVI at the time, found a solution to some of the equations Einstein published, and Johnson just came up with the same solution for one and wrote more extensively about it. There was something strange that happened when with the equation that started to point towards black holes. But at the time, it wasn't well understood, but they were starting to discover the unusual behavior of mass inside what known as the Schwarzschild radius ended up giving us the term singularity, which is commonly used when talking about black holes. Several more scientists worked with the data, and in 1931, Subramania Chandrasekhar calculated that a white dwarf star would become unstable and collapse on itself. Some people were against his idea, but in the end they were both parties right. Some white dwarfs will collapse into a type of star called neutron star. However, neutron stars above a certain mass will collapse into black holes like Chandrasekhar thought. A few years later, in 1939, Robert Oppenheimer and his fellow scientists believed that singularity was a place on the edge of bubble and bubble where time stopped. From an outside point of view, this is true. Stars seem frozen in time as soon as their collapse takes them into the switch of child radius. But if you were falling into the signatory, time keeps going. David Frankenstein in 1958 gave us another common term, event horizon, by taking our precise result and adding that would happen from the perspective of something falling into the singularity. The event horizon can only be rushed in one direction. Martin Huxley had already found something similar, and all of these findings made black holes a mainstream of subject of research. After this point, with lot of people interested, many scientists started to discover things very quickly, and we gained a lot of our current understanding of black holes. They have remained an extremely interesting subject for physicists and astronomers, and new discoveries are still being made. Plus, there is a lot of we still don't know. Types of black holes. Supermassive black holes. Supermassive black holes generally form when the universe was still young. Once a black hole exists in the center of a galaxy, it can continue by pulling. There will be an important research topic because there may be the speeds that have eventually grow into the supermassive ones that galaxies from around. Astronomers thought they probably existed, but it was hard to prove whether one did or not until research started to come in over the past few years. In 2014, astronomers found what seemed to be one in the arm of a explored galaxy, and most recently, in research published in February 2017, scientists found one in the Globular Cluster 47 Triangles that has a solar mass of 200. Generally, scientists find black holes by looking from X-rays coming from a hot disk of swirling materials somewhere out in the universe. But this only works if the black hole is actively feeding on the nearby gases. Inside the center of 42 can there is no gas, so the black hole is unable to feed and isn't electromagnetically bright. This made it even harder to find. 47 was is incredible crowd with stars. The crowding means that the star with greater masses tend to shrink to the middle of the cluster, like something heavy settling in a glass of water. The intermediately mass black hole is capable of causing those stars to spin around it, moving at higher speeds and greater distance. The second piece of evidence for its existence are the pulsar in 4720. If there were no central black hole, there is no central black hole, they would be close to the center of the globular cluster. However, they got thrown out at the black hole gravity and are further away than they should be if there were no black hole. This is compelling evidence for the existence of intermediate mass black holes, and these and other recent findings will help other astronomers find more now that they have an idea of what sorts of things mean as immediately mass black holes might be hiding somewhere. About stellar black holes, macro black holes, how are black holes formed? So goodbye, stay safe, stay healthy, stay home, and don't go to crowded areas. And please subscribe my channel for more interesting videos. Want more interesting videos? So please subscribe my channel, click on bell icon for more interesting videos.